Let us start with tutorial number 4, that is on circular convolution, part 1.
Let us try to solve the first problem of tutorial number 4. You have been given x of k, Dft values of x of n, that is 0, 1 plus j, 1 and 1 minus j. You are supposed to find the Dft of y of n, where y of n is given by 0, 0, 1, 0, circularly convolved with x of n. This sequence 0, 0, 1, 0 can be represented by delta of n minus 2 circularly convolved with x of n. So we will use the property delta of n minus n naught circularly convolved with n, x of n gives you x of n minus n naught to the base n. So we'll apply this. So I'm going to get this as x of n minus 2 to the base 4. Now Dft of y of n, y of k is given by Dft of x of n minus 2 circularly convolved with 4. Let us apply the circular time shift formula. According to time shift formula, we get this as x of k multiplied by w4 to the power 2k. W is given by e to the power minus j 2 pi by 4 to the power k multiplied by 2. So you get this as x of k e to the power minus j pi to the power k. So this is x of k minus 1 to the power k. Now this is minus 1 to the power k and x of k values are given as 0, 1 plus j, 1, 1 minus j. When k value is 0, minus 1 to the power 0 is 1, multiplied by 0 it is 0. When k value is 1, it is minus 1, so minus 1 minus j. When k value is 2, it is plus 1. When k value is equal to 3, it is minus 1, so minus 1 plus j. This is going to be your answer. We'll start with the second problem of tutorial number 4. We'll take up the first part. We have been given x of n. It is equal to delta of n plus 2 delta of n minus 2 plus delta of n minus 3. It is written in the form of sequence 1, 0. When n value is 2, it is 2. When n value is 3, it is 1. We need to find out the Dft. So the linear transformation method. So x of k is equal to 1, 1, 1, 1, 1 minus j minus 1 j, 1 minus 1, 1 minus 1, 1 plus j minus 1 minus j multiplied by 1 0 2 1. This will give us 1 plus 0 plus 2 plus 1. This is 1 minus 2 plus j. Then I have 1 plus 2 minus 1. This is 1 minus 2 minus j. That gives us, this is 2 plus 1, 3 plus 1, 4, minus 1 plus j, 2. It is minus 1 minus j. This is your answer. We'll try to solve the second problem of tutorial number 4. So here he says that y of n is x of n circularly convolved with x of n, and given x of n is equal to 1, it is 0 to 1. Now we need to find out Dft of y of n, that is equal to y of k. First and foremost thing is we need to find out y of n, which is a circular convolution of x of n with itself. So let us try to find out this y of n. So first row will be, I need to start with this 1, 1, 1, 0, 2. So that is what I need to do. So I start with the first one. This one I am going to start with. Then I will move to this one. From there I will move to 2. From there I will move to 0. So I have 1, 1, 2, 0. Second row, I need to move from this 0 should be brought here, 1, 1, 2. So let me write that 0, 1, 1, 2. So the next row, I need to bring this 2 here, 0 here, 1 here, 1 here. So let me bring it. I get this as 2, 0, 1, 1. The last row, if you look at, I have to bring this 1 here, 2 here, 0 here, 1 here. So it is 1, 2, 0, 1. It is circularly convolved with itself, and we know that x of n values is 1, 0, 2, 1. That will give you 5, 4, 5, 2. We need to take Dft of y of n. So I can write this as y of k is equal to, the matrix is 1, 1, 1, 1, 1, 1, 1, minus j minus 1 plus j minus 1, 1, minus 1. Then this is plus j minus 1 minus j multiplied by 5, 4, 5, 2. When I simplify this, I am going to get this as 16 minus 2j 4 2j. This is the answer. Let us try to solve the third problem. Given h of n is equal to delta of n plus delta of n minus 1 plus 2 delta of n minus 3. In the sequence form, this is 1, 1, 0, 2. And x of n is given to us. X of n from the previous problem, we know that it is 1, 0, 2, 1. We need to find the circular convolution of y of n, that is x of n, convolution with h of n, that is circular convolution, not the linear convolution. Now, we will try to solve this. The first row, what we have to write here is, it should move from like this. It should go like this. So, I need to write this as 1, 1, 2, 0. I have written for x of n, so it should be like this. I should move like this. So 1, 1, 2, 0. Next onwards, you know that next onwards, this should come here, these two values will come here. So therefore I can write this as 0, 1, 1, 2, next is 2, 0, 1, 1, next is 1, 2, 0, 1, multiplied by h of n values, that is 1, 1, 0, 2. You get this as 2, 5, 4, 5. Let me now change this. I will make it as y of n. It is h of n circularly convolved with x of n. Now, my matrix will be 1, 2, 0, 1, 1, 1, 2, 0, 0, 1, 1, 2, 2, 0, 1, 1, multiply with, it is x of n, it is 1, 0, 2, 1. This will give me 1 plus 1, that is 2. Second one will be 5. Third value will be 4. And the last value will be 1 into 2, 2, 2 into 1, 2, 1 into 1, 1. So totally it is 5. And if you look at these two are equal, which means that circular convolution is commutative. That means whether you convolve x of n with h of n or circularly convolve h of n with x of n, answer is going to remain the same. Let us try to solve the third problem. And third problem, he has given you v of n. It is x of n plus j times h of n, and Dft values are given to you. Please note, v of n is complex. That doesn't mean x of n and h of n are complex. X of n and h of n are real values, real valued sequences, but V of n is a complex value sequence. This is the first observation you need to make, and he has given you V of k, DFT values, that is DFT of x of n plus j h of n. This is x of k plus j times h of k, and the values are given to you. They are minus 2 plus j3, 1 plus j5, then it is minus 4 plus j7, it is 2 plus j6, minus 1 minus j3, it is 4 minus j, 3 plus j8, and V7 is j6. Let us call this as the first equation. Let us make use of the property. The property states that DFT of V conjugate of n is always equal to V conjugate of n minus k. We'll exploit this property. So we can write this as DFT of V conjugate of n is equal to DFT of x of n minus j h of n. This in turn will give me x of k minus j h of k. That can be equated to the formula is here. When the k value is 0, you know that it should be equal to V conjugate of 8 minus k, because n is 8. So let us try to fit the values here. When k value is 0, it is V conjugate of 8, that is nothing but V conjugate of 0, that is minus 2 minus j3. When k value is 1, it is V conjugate of 7, V7 is j6, its conjugate is minus j6, followed by V conjugate of 6, so that is 3 minus j8, followed by V conjugate of 5, so that is 4 plus j, followed by V conjugate of 4, then followed by V conjugate of 3, then followed by V conjugate of 2, then followed by V conjugate of 1. So now I will call this equation as 2. This is the equation 2. And we know that when I add equation 1 with 2 will give me x of k plus j h of k plus x of k minus j h of k. These two will get cancelled out, so I get this x of k. Therefore, 2 x of 0 gives me minus 2 plus j3 minus 2 minus j3, that is minus 4. Therefore, x of 0 is minus 2. Similarly, I have 2x of 1, that is 1 plus j5 minus j6, that gives me 1 minus j. Therefore, x of 1 is 0.5 minus 0.5j. 2 times x of 2 will give me minus 4j7 with plus 3 minus j8. So minus 1 minus j, that will give me x of 2 is equal to minus 0.5 minus 0.5j. 2x of 3 is equal to 2 plus j6 plus 4 plus j, that gives you 6 plus 7j. So x of 3 is given by 3 plus 3.5j. 2 times x of 6 is given by, x of 4 is given by minus 1 minus j3 minus 1 plus j3 will give you minus 2. Therefore, your x of 4 is minus 1. 2x of 5 will be equal to, now it is 4 minus j plus 2 minus j6, that is 6 minus j7, that will give you x of 5, that is equal to 3 minus 3.5j. And if you observe, this is x conjugate of 3 because your x of n values are real. So 2x of 6, you will get this as 3 plus j8 minus 4 minus j7, that is minus 1 plus j, that will give you x of 6, that is minus 0.5 plus 0.5j. If you observe this, this is conjugate of x of 2. 2 times x of 7 will give you j6 plus 1 minus j5, that will give 1 plus j1. So therefore, you get x of 7 as 0.5 plus 0.5j. It is the complex conjugate of x of 1. Similarly, we can get h of k values. 1, if I take this as 1 minus 2, then this is x of k plus j times h of k minus x of k minus j times h of k minus of minus, you get this as plus. So you have this as 2h of k, j times 2h of k. So I get 2jh of 0 is given by minus 2 plus j3 plus 2 minus j3. You get this as 0. So h of 0 is 0. 2j times h of 1 will give you, that is 1 plus j5 minus of minus, so plus j6. This gives you 1 plus j11. So you get this as h of 1, that is 5.5 minus j0.5. Similarly, 2j times h of 2 gives you minus 4 plus j7 minus 3 plus j8, that is minus 7 plus j15, which gives you h of 2, that is 7.5 plus j times 3.5. Similarly, 2j h of 3 will give you minus 2 plus 5j. So which gives you h of 3 is equal to 2.5 plus j. 2j h of 4 will give you minus j6, that will give you h of 4 is minus 3. In general, I can write h of k is equal to, this is the answer expected from solving the problem, 0, 5.5, j.5, 7.5, j3.5, 2.5 plus j minus 3, then it is 2.5 minus j, 7.5 minus j 3.5, then we have 5.5 plus j 0.5. This is the answer.